Good morning, everyone. Welcome to Automation Alley's virtual Tech Takeover. I'm Tom Kelly, the CEO of Automation Alley. Every Wednesday, we host these member-led Industry 4.0 focus sessions via live stream. This week's topic, a new paradigm, people and robots working safely together in manufacturing. So I'm pleased to introduce to you this morning Mike Folster. He's the product manager for BEHCO, Roberta Nelson, safety compliance officer for Universal Robots, Roman Reiner, application engineer for BEHCO, Caleb Rhodes, application engineer for BEHCO, and Alex Voigt, product specialist for BEHCO. We have a lot of people to share a lot of information with you today. It's going to be a great session. And this is backed by popular demand. This is a re-air of a recent tech takeover we had with BEHCO. And because we view this information as critical, we wanted to share it with all of you again because it's that important. Before we begin, I'd like to remind our viewers that Automation Alley, in partnership with the World Economic Forum, will be hosting a series of virtual roundtable discussions at our upcoming Integrate conference on November 9th. These discussions help Automation Alley define our state's Industry 4.0 strategy and help us prioritize technologies and the topics we focus on throughout the year. So these are very important, and we want you to participate. If you want to be considered for a spot on a roundtable at Integrate, please let me know and we'll submit your name for consideration. And please don't forget to register for Integrate at integrateconference.com. That's INTEGR, the number 8, conference.com, integrate.com, integrateconference.com. If there are any questions, please utilize the Q&A feature at the bottom of the screen along with your contact info, and we'll make sure to get all the questions answered that we get in today's session. So thank you. Thank you for joining us. And now I'd like to welcome the BEHCO team.
The title of our content presentation today is a new paradigm, people and robots working safely together in manufacturing. And we think it's very timely given the demands in the market around safety and people being spaced out. Just to go through our presenters, we're very excited that Roberta Nelson Shea could join us. She is an internationally renowned safety expert. She's a Universal Robots compliance officer, and she's going to take the time to give us all a good, robust safety update. And to that end, I think it's always important to ground ourselves in the reality that robots need to be risk assessed and then deployed in the most serious safety measures possible. To that end, Roman Reiner, our application engineer, has been working hard on 2 products to show off today. The first one is going to be a demonstration on our brand new product for the URAC domain. We've been working with the Universal Robots team, and this is a great story that Roman's going to share about listening to a customer and solving a problem. And to that end, we have been able to solve that problem. We provide now to the general market for Universal Robots a management tool that will allow the end user to protect their risk assessment by having the checksum management tool verify through a safety PLC that the safety system has not changed, adding a layer of security to the engineering and management team. Second, he's going to have a presentation leveraging nut running using Ingersoll Rand fastening system integrated with the Universal Robot, and then applying the new technology from Micropsy. It's the product is called the Mirai, and essentially it gives the hand-eye coordination to the robot and allows the tasks to be taught through iterative process by the operator, so there's no programming. And then that technology through the Mirai system is neural network with AI and machine learning to provide a system that's capable to adapt to real manufacturing tolerance with the idea of bringing these cobots into the assembly process. And then next is Alex. He's going to have a presentation from Cognex. We're very excited to see what Alex can bring to the table. I personally participated in his demo about a month ago, and what they're doing now for machine vision and using machine learning to address quality control is very, very profound. And then Caleb here in Hudsonville, where we're working from today, has 2 demos lined up. He's going to show airskin. That's a product by Blue Danube Robotics. It's a safety rated technology that can be applied to universal robots and other industrial robots to enable more human-robot collaboration. And then he also will demonstrate our Canon 3D bin picking. We now have our second system in place to do feasibility studies. Again, the Canon system is showing itself to be the enterprise solution for 3D bin picking in the market now. Just before we jump to them, I have to take a moment to tell you a little bit more about BEHCO. Again, we're a factory automation distributor. We're focused specifically on the Michigan manufacturing market. We have 4 product groups, including industrial hydraulics, fluid control, motion control, and collaborative robots. And we have an engineering services business that is able to do, in many cases, some light manufacturing, for example, hydraulic power packs, or making panels and other kitted motion control technologies for our customers. We've been a Universal Robots distributor since day one in 2013. To our good fortune, we work with the best collaborative robot in the world. We've seen this emerge from the start as a tool that enables our customers and users to be able to take hold of a robust 6-axis tool and learn how to teach it simply to do tasks that are important to their business. That's why this has been so successful in the market. In order to solve problems for customers, we have aligned ourselves with a fantastic group of technology providers to the market, whether it's software products, 3D vision, mounting, dressing, end-of-arm tooling, vision products. We can handle soup to nuts activity for a customer looking to do pick and place or machine tending activity, providing support around programming if necessary to get you started. I just want to talk again a little bit about the product that is coming to market. The checksum utility is going to be loaded into your UR robot as a UR cap and then configured to allow for a safety PLC to query the robot and verify its safety setting. We think this is important because it's a standard feature in the industrial robot space, and it allows then the risk assessment that in many cases has specific safety settings to be protected from unintended consequences from a poorly managed change. This would sit on top of the robot software and ask the robot to verify that it has the correct safety setting. So to that end, we'll make sure that Roman will go into deep detail on how that's working for you. But we're very excited to be able now to present ourselves at a UR ecosystem. The Mirai system is going to, I think, show what the future looks like in robotic application space. Using the vision systems that's tied with a force torque sensor, we're able to teach this system tasks for which then it's able to accomplish irregardless of the fixturing of the part. It will find the location. So giving it hand-eye coordination and adapting to the real-world challenges of manufacturing tolerance, we see this as a breakthrough technology to study and see where it can take us. Airskin is been in the field now for a couple of years. It's a safety-rated product, and as you can see some of the pictures here, on a robot, it has an exoskeleton that's applied, and then the pads are added. There's also specific designs to cover end-of-arm tooling or act as a gateway between the end-of-arm tool and the robot, or pads that can be configured to solve specific problems for increasing safety of a process. We think this is a great alternative to the scanners that are being used, especially in any high traffic areas. And certainly with a light touch that Caleb will show later, you can see yourself working next to the robot and not feeling the same level of concern with even a force limited stop. And then last of our technologies is the Canon 3D bin picking. This has been presented at previous tech takeovers. I think what's important to show here is that there are different sizes based on different parts. We're seeing this emerge again as a leading technology for companies that are looking for an enterprise solution. It can handle a vast variety of part conditions, and with the different options, it can overcome obstacles that would traditionally make the technology not usable. So to that end, we're excited to show this demo now where we can do work for you and feasibility studies to prove out whether it got the right parts for this technology. So to that end, I want to say thank you again. I'm going to hand this off to Roberta.
Well, welcome everyone. I'm here to talk a bit about safety in robots because that's what I do. You'll get to all the exciting features that will be shown by the other speakers as far as how to make use of the robot, but I talk about how to make use of our robots and ensure safety of personnel. So just what is a collaborative robot? And this is sometimes called a cobot. After all, Universal Robots likes to say, we are cobots. We started it. We're the leaders in the world, and that is obviously a talking point of great pride. But really this term started at, if you can believe it, a boring safety standards meeting in which we were talking about risk. And philosophically, the discussion came to, well, if a robot were to contact a person and the person is not hurt, why not allow the contact? But what we all have to understand is that this is not simply about the robot, it's about the application. So what we're talking about is an application where purposely designed robot systems work in direct cooperation with a human in a defined workspace. So collaborative robotics is not, I bought a collaborative robot that's safe, I don't have to do anything. I don't have to worry about risk assessment, guards, safety fences, cageless robots, yay, whippy. But that is wrong. That is a mistaken idea. The issue about safety is safety of the robot application. So collaborative robots, officially from a standards viewpoint, there is no such thing as a collaborative robot or a cobot. Now I'm saying that simply from a safety standpoint and safety standardization. But we still have all sorts of statistics and PR about collaborative robots and cobots. And it's, if you think it's not an official term, but there's statistics. Well, I guess that tells you the magic of marketing. So these terms really are marketing terms. They're not what's talked about in a standard. But what is talked about in a standard and what's talked about as far as expectations are that a cobot is a robot designed to be able to work side by side with a person, meaning be usable in collaborative applications. That it's easy to use, easy to deploy, easy to get a very quick ROI, and to hopefully open up opportunities for productivity that did not exist previously. So what we get involved in is more or less automating the dull and dirty. The payloads of our robots go up to just under 20 kilos. And so we're not talking about the 1,000, 2,000 kilo robots lifting and moving whole car bodies. We're talking about smaller robots and applications that more often than not, the application is dirty. It could be dull. It could also be quite lacking in ergonomics. And so therefore there's ergonomic hazard. So this is a good thing. And I'd like to point out this little comparison between, I'm going to call traditional robot applications, or let's call it the before collaborative robots versus now what we talk about. And I'd like to point out 2 points because I think this really typifies the comparison, and that being fixed installations versus the possibility of flexible, and the need for extensive space requirements versus smaller space requirements. But this will really seem quite obvious very shortly. And as you can see on the left is a more, I want to say, typical or traditional robot application. And with that application, you'll notice the size or the scale of the robots as compared to what you see on your right, which is basically a robot that is mounted to a tabletop. Just due to the scale of these different installations, it's quite easy to imagine redeploying, moving the robot on the right compared to the one on the left. It's quite easy to understand why do we talk about a smaller footprint, because the robot occupies a smaller footprint. And those are really differences that come to the size of the robot, not so much whether or not you use it collaboratively. Whether you use it collaboratively is what you see in the ease of use, and also what you see insofar as expectations of safety. The example on the left is, again, the more typical or traditional automation in which you have fencing, or what people in the safety field simply call guards, that encase the robot application. So it keeps the automation separate from the people and the people separate from the automation, so that we don't have to worry about any risks due to contact. And then if we look on the right, we do not see any physical barriers or guards that separate the robot from people around them. And there's where we see the big differences. But what enables these big differences? One small piece of it is the fact that it's much smaller payload. But in reality, the difference between these sorts of robots is that the robot on the left likely only has two safety functions that are part of that robot. And those two safety functions are the emergency stop and the protective or safeguard stop. And whereas the one on the right has either 15 or 17 safety functions. So much more than the emergency stop and the protective stop. The additional safety functions are used for monitoring various attributes of the robot, meaning speed, force, power, access position, and so forth. So that you have the capability of limiting how that robot operates, and doing so in a safe way. Whereas the application on the left, the way of limiting is to limit access to it. So those are some of the, if you want to say, the rather typical things to point out as being differences. Okay, for that non-collaborative application where we separated, the thing that everybody has to I understand is that there is a concept called restricted space, and that's the space that the robot application operates within and cannot escape from. I know that sounds like a funny thing to say, but you can program a robot to many, many different motions, and unless the movement is restricted, it goes exactly as far as it can. So one of the first things people are advised to do is, once you know your application, limit the space that the robot can operate within, because that makes your job simpler for trying to make your application safe. So in these traditional applications, we kept everybody separated and people away. So again, this whole concept of the robot operates in one area and people operate in another. Well, we don't have that when we talk about collaboration. And you see here an illustration, which I think is, in some ways I find this humorous, but that's okay, that's just me. We're starting from the very bottom left, in which we've got a rather typical application, the application being in the very bottom left. The operator and the robot application are physically separated. They both go about their business, and there's no touching, there's no interaction. If there is interaction, the robot is in a stop condition and the person can access, and then the person leaves and everything closes up and the robot restarts. If we go all the way up into the very upper right-hand corner, we're looking at a very high degree of interaction. But from my perspective, and my perspective is that of a safety person, I don't see there as being any big difference between any of these applications. The difference that exists is that we go up in the amount of interaction, and as we go up in the amount of interaction, you have increasing safety needs. But no matter what, there is automation and there is some degree of interaction. It could be in the very bottom left, completely separated. Think of it like parallel play with little kids. And then we really are still in the same situation in the box immediately to its right. which would be what we see quite often with light curtains or safety scanners. And then once we remove these safeguarding means that separate people, we have interaction, whether or not it's one at a time, same time, or highly interactive. Those are really all about the same thing. It's just how do you provide for safety? So how do we do that? We do that by safety functions that get described in safety standards, and they're described within the user manuals and the literature provided by robot manufacturers. So the standards part of all this, that's really what I love, because that's the part that I find to be the most fascinating. And yes, I know that's probably a bit strange, but that's me. Okay, we have lots of safety standards, but fortunately in the world of robots, we have a very wonderful global situation in which the international standard is based off of the US's national standard, and the international standard has now, over a period of time, marched forward. It has been adopted in Europe. It's an EN ISO standard and harmonized under the Machinery Directive. We also took that ISO standard and adopted it as the current revision of ANSI RA R1506. There's no deviations, there's no changes from the international. Canada has done the same. Canada does have a couple of minor, very, very, very minor deviations. And as well, Japan, Korea, Australia, and more countries have adopted the ISO standards as their national standards, either directly in keeping the same nomenclature, meaning saying it's ISO 10218-1 or -2, or under their own name, like what the US did with the ANSI-RA R1506, but that's a wrapper around the international. So we have this wonderful situation of the same standard is really required around the world. I'm not aware of another machine that is used around the world having this wonderful distinction. And it really does make life a lot easier for not only suppliers of the machinery, but also end users who have global operations. You can be very well assured that you're meeting 90 to 95% of all local requirements by following what's in the ISO standard, and then you have some small amount of national differences, typically around power and the like. So how can you be sure that whatever you're getting is safe? Meaning you buy a robot and you say, how do I know that it actually meets the standard? Generally speaking, robot manufacturers do seek third-party certification. It is not a requirement to have third-party certification of robots, but most robot manufacturers do so because that is a way to provide, if you want to say, that safety net or comfort to the marketplace of, I say we do what we're supposed to do. I say we comply, but here an independent agency has reviewed everything and they say we comply. So that is also the case with Universal Robots products for both our CB3 series and our E series robots. So we provide a lot of functional safety information. And I can tell you that I have yet to see any other manufacturer provide as complete information and as useful information. Because keep in mind, our robots then get paired with an end effector. We don't know which one. They can be used with many. We don't know exactly what the application is. You're going to see examples of various applications shown today, but there's many more. And they're used for picking and placing, they're used for assembly, they're used for inspection, they're used for sealants, they're used for welding, they're used for all sorts of things. So that integrator who puts it together into the application, whether it's a third party, whether it's your distributor, whether it is the end user themselves, that third party has to make it all work. We make sure we provide the information you need in order to enable an application to be put together and be put together and comply with safety requirements. So we do provide a declaration of incorporation. That is something required for Europe, but it has the unique benefit of detailing in a summary form just what does the product comply with and how are you assured that it is complying with things. In addition to that, there's a complete table of safety functions and descriptions of how they work, triggering events, outcomes, dependencies, and so forth. So you get it all, as well as our PFHD values and everything else. It's important to understand that safety function parameter settings, because for each of these safety functions, well, for almost all the safety functions, you have a parameter that can be set. Let's say it's an axis limit or a joint limit or a joint speed. Let's say it's speed of the TCP. Let's say it's power or a force setting. And each of these are parameter settings for your particular application. And those settings generate a checksum. And you're going to hear today about a utility at a remote computer, if you like, that can be monitoring the checksum and monitor whether or not it has remained the same as what's in the library as having been the proper checksum, or if it's been changed. If it's been changed, there's been a change to the robot safety settings. This may be perfectly valid and it just wasn't properly documented, or this could be an unauthorized change. So this is a great tool to have for safety management and change management control. So which part of these ISO standards applies to me? And I'm saying me, trying to put my hat on for each and every person in the audience. If you're a robot manufacturer, part 1 applies to you. If you are an integrator or end user, part 2 applies to you, because part 1 is about the robot itself. Part 2 is about the robot system and the robot application. And it talks about putting everything together in the requirements. Now, it's very important not to identify yourself by the purpose of your business. As an example, it is quite typical for end users to act as their own integrators. And when they act as an integrator, they're responsible for complying with the integrator requirements. So it is the role you're playing, not the nature of your business. So, important thing to know. Okay, part 2 is about the robot systems and the integration. The application determines the needed robot specifications, peripheral equipment, and any activities to do the job. The robot application includes that robot. So in the example of Universal Robots, either a CB3 series robot or an E series, an end effector, workpieces, and any other stuff, meaning equipment, hoses, cables, fixtures that support the application. It could even be another machine. If it's a machine loading or tending application, you have another machine there and a part's got to go in and out. Well, in addition to those 2 robot safety standards, 1 for the robot manufacturer and 2 for the integrator, there is also something called ISO TS 15066, and that means ISO technical specification. Now, a technical specification is not quite the same as a standard. If you want to think about it in the order of priority or importance, a standard is number 1. Technical specification is number 2. A technical report is number 3. A white paper number 4. And as you go up the chain towards a standard, you are going up the chain towards having a better grasp on what are the issues. So the notion of collaborative robots, collaborative applications was quite new when it came out in the 2012 safety standard. So this technical specification was written to try to provide some more guidance and shape around how to do it. So the technical specification means that it includes requirements. It can make normative requirements, but it cannot disagree with the standard that it supports. So this particular technical specification gets used along with part 1 and part 2. As just an FYI, this particular technical specification was adopted as a RIA, Robotic Industries Association technical report, and I have it listed here. So while it's a technical report in the US, it is a technical specification internationally. The reason it is not a technical report in the US is that ANSI has no allowance for this sort of document. It's either a standard or a technical report, hence it being a technical report. Right now, all of 10218 is under revision. It's not going to be out for a couple of years, but part of the revision is to incorporate the materials that are in 15066 directly into the Part 1 and Part 2 documents. Okay, I mentioned the restricted space. So in non-collaborative application, the emphasis is to keep people away from the restricted space. But we don't do that with a collaborative application. Instead, we have to ask the question, how do we protect workers? Well, we have to follow the standards, the technical specification, technical reports, and there are technical reports that are specific to robot applications. So what's the challenge of doing this? And it's going to sound, maybe a little flippant, but the challenge is reading and comprehension. And all I've got to say is don't give up. First thing you want to remember is if you are planning to get a better understanding of a standard, read it cover to cover. Do not whip out the highlighter at the first page and pick things to highlight. That is not the intent. The standard is cohesive and it self-references within itself as well as to other documents. The most important thing is to understand the scope of the standard, what it's intending to cover, and what it does cover, and then to read it cover to cover. Give yourself a little soak time, then go back. A standard is not to be used where you do a word search and only look up the word you're interested in, because you will lose meaning and you will lose a fullness of understanding. So it's reading and comprehension. So just don't give up. That's all I ask. It does take a little bit, but you can get beyond it. And I can tell you personally, I've had some standards that I've really been challenged to read and even like initially. I had one, I kept printing it and start reading it and I'd throw it out. And I would probably do that about once a month. It took me a year to get through it. So it is possible. It is possible. Okay, robot applications. These photos show you a bunch of different applications using robots. The more typical, if you can see that it's an automotive weld line on the bottom right, you can probably recognize the car, and you can probably recognize that the manufacturing facility is in Europe. We've got a machine tending robot, and we've got a material handling where some cases of heavy parts are being moved around. And then in the bottom left corner, you've got a small little robot that's mobile, because it's on a mobile platform, which happens to be called a mobile robot also. And it is going around within a specific geography of a facility or a room to perform tasks wherever it goes. And the power to the manipulator or robot on top is provided by the mobile platform. But as you can see with each and every one of these pictures, the risks are different. So if you were to go in and say, what should I be worried about as far as risks people be exposed to, the risks are different in each and every one of them. So yes, there is a risk of getting hit by something, but how heavy, how hard, and where is there space for work to be performed? Are there thermal risks? Are there any sort of laser or welding risks? All of this means that the risks are different, the risk assessment will be different. So because it is about the application, the questions that have to be asked when doing a risk assessment is, can the robot injure a worker? Can the end effector injure a worker? So more often than not, the end effector and or the workpiece is the most dangerous part about that application and not so much the robot. Can mobility injure the worker? In the case in the very bottom left, as it's whipping around through the facility, is the issue of the mobility the greatest risk? And if so, what are you doing to protect people from those risks? That could be as simple as safeguarding devices that will slow down that mobile platform, for example. So risks can be obvious, sharp edges, pointy things, but not always obvious. The risk assessment process reveals all the hazards, not the easy to identify sharp edges and pointy things. And to that end, there is a resource available, and I have included the link here, that's available from RIA, which is a risk assessment methodology. It really steps you through everything. And what I do need to point out is that risk assessment is scary if you've never done it before. Each time you do it, it becomes easier and easier, and all that it takes is a few under your belt, and you say, risk assessment, I got this. I know how to do it. I feel comfortable. The most important thing is do it, be consistent, and be thorough, but don't be paralyzed about doing it or not doing it. So you've done your initial risk assessment. Now what? You need to design and implement your collaborative application. So we've got a few different techniques, and if you know these concepts, that's great. The world that we tend to play in, meaning as Universal Robots, is the bottom one that's in highlighted color, a robot with power and force limiting. And it tends to get used just as that for interactions, or sometimes combined with speed and separation monitoring. So remember I said it can be overwhelming to do the risk assessment, but don't be overwhelmed. The whole notion of the risk assessment for context, if it's a power and force limited application, is just an added step. And you can get through all this. But let's say you're not prepared to expand your risk assessment. You don't have to do that. You can do speed and separation monitoring with our robot. If you are ready for it, there is another RIA resource for how to check to make sure you're not exceeding limits, and that's for power and force measurements. So you've got all of these things. And you also are going to have a presentation by airskin, which would be another technique that could be used. And it could be used as a nice start to doing your collaborative applications and starting very simply.
Very good content. Thank you for queuing up some of the other technologies that we're going to present and giving us a thorough understanding of the demands for the application space, and also giving us more confidence that although the demands are real, they're manageable if we put the effort into it. So I think at this point we're ready to go to Roman.
Hello and welcome. I'm extremely proud today to show off the checksum verification utility from BEHCO. It is a utility that we developed with a Tier 1 automotive manufacturing company. Through a few development processes, we were able to communicate over all the major communication interfaces that the Universal Robots have. And it was a great learning process, and it ended up being a project that I was extremely proud to present and show off on the UR Plus website. So it works through the quick start guide provided by BEHCO. Once you've installed it, then you'll get a few functions. These functions initialize variables that are sent to your external device. As mentioned in the prior presentation from Roberta, thank you. This checksum value is an important value for monitoring your safety settings to ensure that nobody has maybe accidentally changed the values or changed anything that could alter your risk assessment. So this is an important for our Tier 1 automotive company that we worked with closely. And in the end, we came up with these three functions, one of which was a string variable, and the other two are integers. This allows you to communicate over Modbus, Profinet, and Ethernet IP. So in some specific instances, the PLC may not take a string variable, and that's when you'd use the other two variables and combine them together to get your checksum value. BEHCO checksum verification utility, as I said, is now available on the website. And I'm extremely proud to present it, and that's really the whole gist of the utility. And with that, I will pass it over to Caleb.
My name is Caleb Rhodes. I'm an application engineer at BEHCO. First off, I'd like to thank you guys for taking the time to join us today. for our first virtual Tech Takeover. It's a little different, so hopefully you're enjoying the presentation so far. Today I'll be giving you an overview of the airskin product along with a live demonstration. So what is airskin? Airskin is a pressurized safety suit designed to wrap or box around your automation equipment. It is designed and manufactured by Blue Danube Robotics out of Austria. And what the airskin product allows you to do is to add a PLE Cat 3 safety certified product to your new and existing automation equipment. Now the pads are all the same, and they're made up of the same 4 components. Those 4 components are an airtight hull, a pump, 2 sensors, and some electronics. The controlling all of the pads is one microcontroller. So the microcontroller has 6 wires here. The whole system is powered off of 24 volts. There is a ground wire, and then the remaining 4 wires are your OSSB signals or your 2 safety redundant safety channels. Now, coming out of the pigtail here to the flying leads, this is where you're able to give your system power and connect it to ground. And then your 4 safety channels, or your 2 redundant safety channels, plug into your safety inputs, either on your safety PLC, or if you were to use it on a linear actuator, it would plug into your safety inputs on your drive. Now, coming out of the other end of the safety controller is 1 cable with 6 wires. Now, these 6 wires are the same. It's over here, and this plugs into your first pad in your system. Now, the first pad in your system, you're going to connect to your H. These are labeled, these 2 PCBs here, a hot and a cold. The wire plugs in directly to the hot, and then connecting more pads in series. You can connect up to 15 of them. You then connect from the first pad out the C into the second pad of the H, and so forth, going along your whole system. Now, there's 2 different types of connectors. The first one are these flat connectors that plug directly into the PCB chip. The second ones you see are here on the robot. These are magnetic connectors. They are IEC 62061 certified, and they follow that standard, which is basically just a standard that's functionally safety rated for electronics and control systems. Now, how the system works is each pad is continuously monitoring for the change in air pressure. When a deformation is detected, it runs back to the controller, and the controller signals that a collision was detected, and then it puts your automation, in this case, the robot here, into a braking sequence. Now, really, the airskin products can be broken down into 3 subcategories. The first one is the modular pads that you see here on the front of the table. They come in 4 sizes. The first one is 200 by 100. You also have a 200 by 200, a 300 by 200, and a 400 by 200, which would be the largest pad. Now, again, you can connect up to just 1 or 15 of these pads in series. You can put them into any orientation or any configuration you want. So mainly these pads are used to build up around end-of-arm tooling. You can put them on mobile robots or, again, on some type of other actuators and linear motion that you want to add safety to. The brackets on the back side here are 3D printed. They allow you to connect it to a flat surface, so aluminum extrusion or some other type of material. Then simply the pad is magnetically connected to the bracket to complete your system. The second product is what you see here on the robot, which is, again, these 3D printed brackets, but they're customized to the specific joint dimensions and the lengths of the arms to give that robot kind of an exoskeleton that wraps around the robot's profile. The robot's products for airskin, there is Universal Robots, obviously, KUKA, Denso, Mitsubishi, Staubli. They're working on a few others like Fanuc and Yaskawa that are to come out later in the future. The installation time for this specific unit on the UR10 was about 30 minutes. Now that I've done it once or twice, I can probably do it in about 20, so you get faster as you go. The last product here is the safety flange, which is mounted directly between your robot tool bracket and your end of arm tooling. So it's this white pad you see here, which acts just like any other of the pads. Excuse me. The only difference is inside of this pad is a spring. And that spring, there's 3 different springs based on the amount of payload you have on the end of the robot. So the first spring is between 0 and 2 kilograms. The next spring is about between 2 and 10, and then the third spring is 3 and higher. So they have different spring constants for different payloads on the robot. And what the safety flange does is it detects axial motion, angular motion, and torsional motion of your end of arm tooling or collisions with a workpiece per se. It's a great product to add to any robot. The connection is the same. It connects to the last pad on your robot. It has 1 input. So that's basically how it works. I will speed up the robot for a live demonstration. Right now I'm running at about 30%. So we'll crank it up to about 1 meter per second at 150 newtons that it's outputting. As you can see, each pad reacts when a collision is detected. There is some visual feedback. If I pull this one, you can see it lights up red. So red is showing that there's a collision on that pad. I think you can see here as well. When a pad goes yellow, it means that there is a break in that electrical circuit. And then blue means it's fully operational. There is another visual feedback green, which is only on setup and configuration. I'd also like to mention that there's no additional programming done on the robot side or on this microcontroller. It is directly connected into your safety PLC, and that's all you have to do. So there's no programming, there's no additional configuration, no additional software that has to be added to the products. Each pad is IP50 rated. The reaction time of the pad is less than 9 milliseconds. So the remaining mechanical forces for the stopping distance are then absorbed by each pad. So if I was to put my shoulder up here, it reacts in less than 9 milliseconds. My shoulder goes back into the pad. It limits the pain threshold. The magnetic connectors here on the joints, it's pretty cool because you don't have to worry about having a wire shear if it was to get caught. It simply just disconnects and then it snaps back in magnetically and then it resumes operation. So you can either have the robot operate or be able to resume operation after a collision. You can also run a safeguard reset into the robot. So if you wanted to have an operator come up, touch the robot, do some type of work on a workpiece, step away, they can then signal a digital input like a button or a switch, then the robot would be able to resume operation. I think that's all I have for you today. If you have any questions, please remember them or write them down, and we'll be happy to answer them at the end of our session today. So thank you for your time again. I'll turn it over to Alex for his presentation.
All right. Thank you, Caleb. A little background on me. I am the product specialist for our deep learning and AI systems. Today, I'll be going over essentially how we collaborate with UR for any guidance applications, as well as our new deep learning AI solution. So a little background to Cognex is we have been an industry leader in machine vision for over 38 years. We've been trusted by over 25,000 customers, and we are global. So we have offices in over 20 countries, so we can support our customers, give consultation advice as far as the systems they've deployed. And we've also shipped over 2 million systems to date. About a year ago, Cognex actually developed UR caps, which essentially enabled Cognex and UR to seamlessly integrate with each other. Typically, with any robotic applications with machine vision, it's fairly difficult to communicate between the robot with the cameras and to calibrate to essentially find any parts in any type of movement applications. Looks like the video is pausing here. So essentially here, you can see that we're fixturing off of this part, we're locating it and essentially sending those coordinates to the UR robot to do any type of pick and place applications. With all of our Cognex systems, they are smart vision systems, which means you don't need a controller or a PC to process any of the equipment or any of the communication protocols. We can actually develop your program and send that data directly to a PLC or UR robot. So the next part of the presentation, I'll actually be going over our first ever deep learning enabled insight vision system. Similar to the other Cognex systems, this is a standalone system, meaning that all the processing is done on the Cognex camera here. I'll be going over some of the applications that requires deep learning, some of the applications we can handle, and then going over the features of it. And at the end, I'll be going over a live demo of this. Some of the features of the system, we do have about 15 gigabytes of storage memory, which the reason why that is important is because when using an AI technology, you essentially need to train images and save images to your database and to your program. Having a lot of storage memory is very important so you can save those images with the job program so you can be online. This is IP67 rated, meaning that it is rugged and meant for the factory floor. We do have a wraparound pass-fail indicator, so operators can see, essentially if you're passing or failing the job without even going to the system. We do use 24-volt power I/O and Ethernet communication. We also have a third light port, so if you want to trigger and use external lighting, you can actually program that directly from the camera and power it as well. This does come with Cognex ViDi, which is our deep learning algorithm, and it also includes HDR. For those of you who don't know what HDR means, it stands for high dynamic range. Maybe if you're streaming a movie, you might see a little HDR symbol at the top right of your screen. Essentially, this enhances the contrast of your image or of your video quality. And why that's important in machine vision is essentially you want to get high contrast in your part, and I'll show you why that's important in order to do any machine vision tools for that matter. And we are first releasing this in 2 megapixel and 5 megapixel image options. And this is a grayscale camera, meaning it is in black and white. However, we do have plans to release the color version here in the next couple months. So with the first application that we typically look at for some of these deep learning algorithms is our defect detection tool. Now, for those of you who have experience with machine vision systems, typically looking at applications like porosity or surface defects, such as scratches and dings, it's very difficult to program these in because not every scratch is going to look the same. They're not going to be in the same location of the part. So it's very difficult to train and program a system like that, especially when you have confusing backgrounds like this screw. However, using deep learning, we're essentially training on a subset of good images or what the quality person considers good. And by finding any anomalies in the image, our ViDi detection algorithm will essentially find those anomalies and classify that as a defect. The next deep learning tool that we developed with the system is our OCR. So for those who have done anything for serializing your parts, as far as, maybe reading the contents of your product, typically in traditional machine vision tools, it's very difficult when you have curved surfaces or maybe your print quality isn't 100% from part to part. Maybe you have ink drip, or maybe it's a very difficult to read direct part mark. Using our deep learning and training off of 30 to 50 images, essentially, we're able to account for all those variations. And even with this, good example I like to have is with the 7. You can see how it's on this curved surface. The geometry of the 7 is going to look different here as opposed to if it was here. But to me and you, that both looks like a 7. So training a deep learning and AI system operates in the same fashion. The next is our VIDI check for assembly verification. This is to make sure that all the components, oh, did I lose? Can everyone see my screen right now? Because it shows I'm sharing it, but. Okay, all right. So with VIDI check, this is our assembly verification. So this is to make sure that all the components in your product are present and in the correct location. Traditionally you can use, pattern tools or blob tools to, do this in your traditional machine vision systems, but sometimes you might have a lot of variation as far as how the product is placed. Maybe you have a lot of different product variations with it. This is essentially a lot simpler solution to deploy. It's basically training on your, on your contents as well. So the last part of this is I'm going to actually do a live demonstration with the deep learning system. So obviously I'm not able to give this presentation, in person, but this is the setup I have. I have my Insight D900 system here, where I have a red integrated light and autofocus lens. So as you see the live feed, you might see some red lights flashing. That's the reason for that. I also have a webcam here just to show, what I'm putting under the system. That way you guys know I'm not pulling any tricks on you guys. I have this connected directly to my laptop. You have an Ethernet cable basically coming into here. And then I also have my development dongle, which is needed to train all of my images. Now, the application I'm going to solve here is I have 4 different weave carbon fiber cards. So you can see that the weave style is different as I go through my 4 different good cards, but I have some defects on the same weave styles. It might be a little difficult to tell because this is a fairly confusing background, but see I have a little misthread right here on all these different cards. So with that, I am going to go into the live demo. So to give an overview of the actual program, for those who are familiar with Cognex, we're actually utilizing our spreadsheet environment to make any programs. We have our toolbox here where I can, use our traditional machine vision tools as well as, your deep learning tools, and you can use them in conjunction with each other. So for this one, I'm actually going to train on this Cognex logo and use that as a fixturing tool. So as I rotate the part, it'll essentially move with it. Now with this system, we're also utilizing a web HMI interface. So with this, my URL is essentially just the IP address of my camera. And, this allows me to make changes, look at the program and, kind of see how the program's reacting. So you could do this on your phone as long as you're connected to the network, things of that nature. Now, at first glance, this is a pretty low contrast image. I have a black card on a black background. So if I trigger, you'll see the lights flash. Pretty difficult to see a lot of those features. However, if I enable HDR, which is what I talked about earlier in enhancing the contrast, you can see I get a lot more of those features with this card. Now I can turn the system online where it's going to constantly trigger and you'll see that red flashing. Now if I can rotate this card, essentially we're passing, and this VIDI graphic where it's showing this red box is where I'm looking on this image will move as I move this Cognex card. I can place, that was OK1. Here's a different weave style, which is OK3. I can move this card as well. But what happens when I throw a defective card under it? You can see quickly as I put that under there, not only is VIDI locating where that defect is, but it's actually highlighting it as well. And if I hide this, you can see, that's that defect. And VIDI was able to identify that right away. Let's say if I were to, I'll try to time this out well, draw a little mark, on this card as well. I did that pretty quick, but you can see that I have a little mark there. And if I hide this, if I zoom in, that was that mark that I just made with that pen. And I'm processing all of this within about a fifth of a second here. I'll move this card around. You can see that it's continuing to find that. I get my hand out of the way, and then there's another one where I'm passing, that good card as well. And with that, we can also have some traditional tools with this. So, as well as doing our deep learning and finding those defects, we can also read, any types of barcodes, do any pattern matching as well. So here I'm reading this code, outputting the contents of the string, and you essentially see that. So that's the last part of my presentation. If you guys have any, applications that you essentially want us to take a look at, we're definitely happy to do any feasibility testing on your parts. Feel free to reach out to me, or you can go to cognex.com and request a demo, and we'd be happy to work with you guys on that. So with that, that's everything I have. I guess I'll kick it over to Roman.
Thank you, Alex. And I'm standing in front of our UR5E with hand-eye coordination, thanks to the MirEye technology from Micropsy Industries. I'm going to go through what the components we have set up here is we have an Ingersoll Rand controller with a nut runner and a USB camera and a force torque sensor. So today I'm going to show and demonstrate the socket going to the top of the bolt and fastening and torquing the bolt down. I did this through a series of training with the MirEye box, where I manually would move the robot to a position above the bolt and record the training session. It's a really neat technology, and I'm really proud to bring it to the market and demonstrate it for you guys today. With that, I'm going to have cart roll over here so you guys can get a better view, and I'll start the demo up. So I'm going to talk as I go here. This first fixture is going to be stationary, and you'll see that I'll start at a reference point above the bolt and activate the MirEye system. MirEye system will move to the top of the bolt and fasten it down. So I'll do that first. As you can see, it found the bolt, engaged, and now it's going to unscrew. And now for the other fixtures, I'll show a little bit of randomness to demonstrate that these aren't fixed locations. So I'll move them a little bit left and right here. Then I'm going to fasten them down. Sorry if it's a little loud. Continue on with the program. So you see I'll start at another reference point above this fixture, activate MirEye, and it's activated, skill complete, and it's torquing down the bolt. I really like this technology, one, because I did most of the training on this fixture too here and was just able to start from those reference points and activate MirEye without doing any other programming. It was all generic for the other fixtures. Really neat tool, uses machine learning to train through a Python server that communicates with this MirEye box here. And as you can see, it was successful in all those fixtures. It was a good demo. With that, I could go through it again and demonstrate it again here a little bit. After this is done, I'll pass it over to Caleb. Last but not least, for the Canon RV1100 demo out there. So go ahead, Caleb, take it over.
All right, thank you, Roman. Looks like my screen is sharing correctly, so that's good. Thank you guys again for staying tuned. My name is Caleb Rhodes, like I said before, an applications engineer at BEHCO. For this final presentation, I'll be giving you a quick overview of the Canon RV bin picking demo. On your screen, you are seeing the Canon software along with the live feed of our bin of parts. So just a quick background on Canon and what they've done to come to market with this technology. So Canon, as you all know, has been in optics for decades with all your personal photography cameras. As now more people are getting rid of their handheld cameras and moving more to iPhones or smartphones, Canon has taken the opportunity to move into a new channel and assigned 70 engineers in Japan the responsibility of creating a product for the industrial automation space. What they've come up with is what's called the RV machine vision series. And what that allows us to do is do 3D bin picking applications. So a quick overview of the products. There's 3 products in the RV series. They are all the same dimension, so they all use the same vision head. The only thing different is the optics inside the vision head. There's 3 sizes, the RV300, there is an RV500, and an RV1100. And those are basically just field of views and how, basically what the distance is mounted above the bin. So the RV300 would be your smallest bin, smallest part size, and the RV1100, again, would be your largest bin, largest part size. Now, the Canon Vision Head is connected to an external PC, which is running the software you see here on the background screen or the larger screen. This is where all of the configuration and setup is completed, along with running a runtime window when the application is running. This external PC is then connected to your robot controller through TCP IP socket communication. And then from there, the robot would be able to go into the bin and pick out the part precisely. So just a quick setup of the software. There is 4 inputs into the system. Those 4 inputs, the first one being your bin or your pallet. These are all CAD models that are entered into the bin. For the pallet, you're able to enter in the dimensions rather than creating a CAD model. We'd recommend you creating a CAD model if you had a more complex bin, something with irregular shapes other than a box or a rectangle. So that's the first input. The second input then is your part. So CAD of the part. So when we do feasibility studies, typically what we ask you is to send us a box of your parts. Between 10 and 30 parts is perfect, along with the CAD model of the part. So the CAD model of the part is loaded into the system as a step file. The third input is your end of arm tooling, or in other words, your gripper. Here we have a pretty complex gripper, which is actually 2 grippers on a 45-degree angles to the tool of the robot. So again, that's loaded in as a step file. And lastly, the last input is your grasp. So teaching your CAD model of your part and how you want to grasp it with the end of arm tooling. And here is pretty generic. This actual end of arm tooling isn't designed for this part. I would definitely use something different. But for just showing you today, this is how we load in and teach grasp. So those are your 4 inputs into the system. When we go into work recognition, what it's looking at is it's taking all those CAD model inputs, and the Canon will take an image. It's using structured light to sweep across the bin. When it does that, it creates a point cloud of data, and that data is then CAD matched to the CAD model that you loaded in of the part. The other CAD models, such as bin and end of arm tooling, are specifically used for collision detection. And that collision detection is either with the side of the bin or other parts that may be touching a part or underneath the part that aren't able to be grasped correctly. So here we are simulating a feasibility test. We don't have a physical robot hooked up. Mike Folster, who started us off today, is acting like the robot. So I am cycling images here on the screen, and Mike is going in and picking out the correct part. If we switch views, so right now we're in a 2D image. We can switch to a 3D image, which is a depth image, and you can see the point cloud that the cannon generates. And then you can also see the CAD that's being matched to that point cloud. So hopefully you can see that correctly. If I zoom in a lot, you can get down to every single point. But we'll keep moving through here and have Mike empty the bin for us. So that's all I really have to add. Actually, no, it's not. There is a couple options to go along with the cannon. Excuse me. There's 4 options. The first one is partial part recognition. So what that does essentially is if you have a large part that expands beyond the field of view, we're able to look at just a certain portion of that CAD model, and then extrapolate and do work on the whole part itself. Also, if you have a part with a lot of variance, so think of like a bolt with a floating washer, the partial work recognition will allow us to max certain parts of that CAD out of the system, so we can get rid of that variance and just look at the head of the bolt if that's what we want to pick. The other options, consecutive recognition is the most popular option that we typically sell in a solution. That really accelerates the cycle time of the application. So basically, a consecutive recognition, we're taking a scan, taking out the part, and then consecutive recognition is then taking a 2D image of the bin and seeing if any of the parts have moved. If none of the parts have moved, then we know that we have good points on the other parts, and we're able to go in and pick precisely on those parts. So again, if you have demanding cycle times in your application, that would be an option you'd want to use. Third is batch recognition or multiple bin. This allows you to handle multiple bins in the process. So under one field of view, you could have 2, 3, 4 different bins with different parts. And then with one scan, you can pick up a part in each bin. So you could essentially pick 4 parts from 4 different bins with one scan of recognition timing. Last is the slider mount option. This allows you to mount the 3D vision head to a slider or to a linear axis of motion, whether that's horizontal or vertical. Basically what it does is, for example, say you have 2 bins, and the first bin is empty. You want to slide over to that new bin of parts and start picking from the full bin of parts. Also, if you want to get deeper down into the corners, so if you have a very tall bin, you could put it on a vertical axis. So basically what it allows you to do is take measurements from 2 different locations, essentially. That's pretty much it. If you have any questions, again, feel free to write them down. I'll turn it back over to Mike for the final remarks. So thank you for your time.
You've been able to see here a number of technologies that are really on the doorstep of what Industry 4.0 is all about, whether it's the digital representation of product in a bin that can communicate to a robot, or if it's machine learning based on the ability to use the AI neural networking technologies from Cognex or from Micropsy. We're seeing now that emergence to simplify application deployment or expand the collaborative domain by taking robots to places where they would be challenged to work otherwise. So if we did a good job for you today, then hopefully you feel more comfortable about the safety domain in terms of what's required. Thanks again, Roberta, for taking the time to go through the details. They matter. We've also are excited to bring new technology to the table to make safety even easier to deploy, whether it's through industrial setup where the checksum management activity is critical. We've now got a product available through either our website or the Universal Robot, the UR Plus domain, to solve that concern and give you more confidence that a management product is controlling the safety setting. We're also excited about bringing airskin to market here in Michigan,
We think this is perfectly timed to address the challenges of spatial relationship on the production floor. And when we can add intelligence to the robot to allow it to accommodate for part-to-part variation in manufacturing, we will start to see where cobots can be used in the assembly process. And to that end, we're going to continue to push the fold on Industry 4 technologies. Our team is capable of showing these demonstrations again if needed. If your team is interested in learning more, please let us know, and we'll be glad to organize that activity for you. I owe one shout out as well to Alex at Cognex for taking the time and effort to bring that technology to the table. And again, I think in terms of anybody watching and looking at how you can now address quality control concerns using flexible automation with high-powered devices from Cognex is a real solution. So thank you for that demonstration, Alex. And thank you to the BEHCO team for all the hard work and hours put into getting our demos prepared and the presentations tied together. And of course, Rebecca, Cynthia, and the entire Automation Alley team, we wouldn't be here without your support. So thank you again.
Great. So thank you to the entire BEHCO team for a terrific and informative tech takeover. And thanks to our viewers as well for tuning in today. I hope you enjoyed the session. Just a reminder that this event and all our tech takeovers are archived on our website for you to view at your convenience anytime in the future. Thank